All right, I'm going to go ahead and give you the answer to the first two problems where you had to find the graph features. And while I'm doing that, you might also learn some new techniques or some things that maybe you didn't notice. I didn't say do this a certain way, so you could have easily used your graphing calculator for this, and that's okay. We're going to go over in class on how to do this without our graphing calculator. Let's look at our first equation there. I notice I have negative coefficients. So right away, I know that this is going to be one of those quadratics that opens downward. But I also want to make sure that I'm distributing that negative, because if you notice from the last problem, you could get the intercepts from the terms inside the parentheses, but that only works if you're distributing any coefficient you might have to that first binomial, like I did in here. So what I'm doing now is I'm checking my answers just to make sure that I went ahead and did that correctly. And what you're going to find is once we have this set to 0, your intercepts are going to actually be accurate if you distribute that negative. So I went ahead and graphed this on Desmos just to make sure my intercepts that are -2 and 5. And there they are. It's always good to check your answer while you're doing it. Once I have your intercepts, your x-intercepts, you can get the axis of symmetry, and we know that by combining these two together, they're going to be 3.5 units apart. And so you can count 3.5 units in one direction, 3.5 units in the other direction, and get to that middle point, as I'm doing right now. And it's hard to see, but that's what I'm doing. And I'm drawing my axis of symmetry, and that is at x equals 1.5. And I'm going to show you later in this video a trick. Let's look at some intervals. We have an increasing first from -infinity all the way to my vertex at 1.5, and we are now decreasing from 1.5 all the way to positive infinity of x values. So that is those are my intervals. Now you really didn't have to get the domain and range, but since we're here, we might as well look at it. So what would the domain be? Now remember, your domain are your x values. So if I'm looking at all the x values, then I'm noticing that all my real numbers are going to be part of that. Now, what is your range? That is all your y values, and you notice that they start at -infinity all the way up to y is 12.25, and we don't have the parabola going up after y equals 12.25, so that's where it ends. Let's look at our second example because it's not in factored form, and I want to go ahead and put it in factored form because it's just a lot easier when you have things in factored form to get your graph features. And with your graph features, you can go ahead and start graphing. I went ahead and did that in Desmos. You always want to make sure you double check, and I'm going to actually do the math by hand. I like to double check, just like you use your graphing calculator to double check, I use Desmos. So I have my equation up there, x squared minus 5x minus 24. I'm going to use the product sum method because I have a +1 coefficient, and I'm looking for factors of -24 that add up to a -5. And I found it. If I have a -8 and I add that to a 3, then I'm going to get a -5. So I'm going to go ahead and factor this. And once I factor it, then you're going to see that it's going to look like the factored form that I wrote the equation in red. So once I have this, then you know your intercepts are going to be the opposite. So x is going to be 8 and x is going to be -3. Once you have your intercepts, you can get your axis of symmetry because they're directly across from each other, and the point in the middle is where your axis of symmetry is. And I've shown you how to do that, but I want to show you a little shortcut here. If you just add these 2 points together, so if I add 8 and -3, I'm going to get a +5. And if I divide that 5 by 2, I'm going to get a 2.5. And look at your x value here. Isn't that what the vertex has for the x value? I've shown you how to get your axis of symmetry by getting the difference. And so now you just have another quick, fast way of doing the same thing, basically. And we're going to practice that more in class. So don't worry if you didn't just get it right now. Now I'm going to, once I have my x value, substitute it for x and try to find y for my vertex. And all I did was plug in that 2.5 there for every time I saw x. And now I'm going to get my y, which is going to be -30.25. And I already know that because I graphed it and so I can see it, just like you can graph it to check your work. All right, so once I have my intercepts and I have my vertex and my axis of symmetry, I can look at my intervals. We're not going to do that right now because that's not the point of this one. I just wanted to show you that quick bit on how to get your vertex from factored form.